Well, good morning, everyone. Welcome to the C&E Sales Monthly Webinar Series. I'm Jeff Butler, the Technical Manager here at C&E. Today's webinar is titled Safety Integration for VFDs. Your presenter today is Jay Swank. He's a motion specialist here at C&E, and he's been in that role for 4 years. Been with us for 5 years. He was one of the automation guys prior to making the transition over to a motion position, and then he came from one of our OEM customers. Just a few housekeeping items before we start. If you have questions during the webinar, please submit them using the control panel tool on the right side of your screen, and we'll address them at the end of the session. If you don't see that tool, click on the red horizontal arrow and it should open up that dialog box for you. Everyone who's registered for the webinar will receive a link to the recording. So if you want to, you don't necessarily have to take notes. You could go back and review it later if you'd like. And if you get a chance, please come to next month's webinar. It's hosted by Doug Hammer. Doug's our control product specialist here at C&E, and his topic will be the Siemens new 3VA circuit breaker. Siemens has a new line of molded case circuit breakers, which Doug will be covering. And that webinar is on August 10th at 10:30. I'll now turn today's webinar over to Jay.
Thanks, Jeff, and thanks to all of you who are joining today. As the title sort of implies, the safety integrated for drives, specifically what I'm going to be going over will be the Siemens general purpose drives, or your VFDs. I will touch a little bit on some of the servo safety as well. And one of the nice things with Siemens is whether you're using the older classic starter to configure safety or whether you're using start drive, all of the configuration is the same. The parameters are the same numbers really across the drive family. And we're going to look at some of that configuration as we dive in here a little bit deeper. So with that said, let's get going here. So whenever we look at a safety application, there's different levels of it. A lot of our attention is put into e-stop buttons, safety switches and contacts, and then also the evaluation side where we've got, either a safety relay, safety PLC, and I/O. These devices here are covered through our automation safety specialist, but really where I'm at is over here on the respond to safety. The drives, or the things that are actually causing the motion that really is where the concerns come with safety anyway. If our machines all sat still, then there wouldn't be a whole lot to protect. So that's why it's always a hot topic on how we can safely control motors and actuators and parts like that. So again, we're going to be really focusing over here today. The main drives in the GP family that include safety, we've got the G110M. This M stands for a motor-mounted drive, and it's a modular drive. It's a little backwards built. The control unit's on the bottom. The power module is on the top. It's a little bit different. The intention is to mount this directly on top of a gear motor or Siemens motor. And in that orientation, this box would be replaced, and it would connect directly to the junction box on the motor with some connectors. As shown in this picture, it has a wall mount bracket, which really makes it usable for just about anywhere. So with a gland mounting, this is an IP68 drive, can be mounted outside the cabinet up to about 5 horsepower, includes safe torque off and safe stop 1. And I'll get in deeper here in a little bit about exactly what that means. The G120 family, G120 and G120C, the compact version of it, that's the bread and butter modular drive. We've got a power module, we've got a control unit, and then we've got an operator interface. And you need at least these two to make up one drive, and then this operator interface would be accessories that would go with it. Not all power modules or control units in the G120 family have all of the safety features. So I'll go over what safety features are in what control units here as we talk. The G120C is sort of an all-in-one drive in that it comes with a control unit and power module, and then you still order accessories like this operator interface you can see on the front. This is an IOP, and then this is a BOP. Included with the G120Cs would be your safe torque off. G120E is an enclosed drive, kind of goes to the floor, or mounts right to the floor. It's all been seismically tested. We've got short circuit ratings. It's a very nice product. They're configured and engineered. And really what you have is G120 components in addition to any bypass contactors or switches or anything else that you would have in your configuration with it. So safety often aligns directly with the G120. Certainly configures the same. G120D is a decentralized drive. We go up to a little bit higher horsepowers in the G110M, and again, it's modular, and we have a whole host of safety features that can go along with it as well. Some other drives that are out there, the G130, G150, and then I went ahead and clicked in here the S110, S120. These are servo drives. The S series are typically found with servo applications. That being said, there's some cases where, due to the common DC bus and the way the system architecture goes together, it really can be very competitive, even for frequency type volts per hertz or power applications. And then that certainly goes has all of the safety features as well. The reason I sort of mentioned those servo drives is that the S120 hardware, meaning especially the chassis size units, while these are in the general purpose or VFD, so to speak, family, the larger horsepower and nature of them means they share internal componentry with the S series family. Now, don't concern yourself or wrap yourself up with that too much. It's not that you have to know every one of these drives differently. Really, you select the hardware based on the application from a software parameterization and configuration standpoint. It's 100% the same. Provided we have a drive that has the features you need, whether we're doing starter or start drive, the configuration's the same. The primary safety features that I'm going to be discussing today that are included in that family is, of course, safe torque off. Then we also have safe stop 1, safe brake control, SBC, safe limited speed, safe speed monitor, and then safe direction. That's actually safe direction input, the SDI. These acronyms are referred to throughout all the Siemens documentation, so it's kind of nice to get yourself familiarized with what they're talking about and what they mean. I'm not going to focus too much on the exact chart. I'll do that a little bit more in depth, especially while we're configuring. Safe torque off is absolutely the most common thing that people are looking for in a drive. That's what I hear. When I ask, do you need safety? And I hear, yes, I need safe torque off. And that's fine. One point of caution with just about anybody's drive that includes safe torque off, most that I've found in the industry, including Siemens, safe stop 1 will finish with safe torque off, but it includes a safety rated and monitored ramp. Now, what I see a lot of times with safe torque off is people will configure a fast ramp, but that's not safety rated. Now, that's completely fine, with exception that if your risk assessment or safety is requiring your drive or that axis to bring the motor to a stop in a certain amount of time, really that's a safe stop 1 application. And why that's important is with some drives and control units, safe stop 1, that SS1, is actually an extended safety function. It's not a basic safety function that comes on some others. So if you're using a fast ramp and it's required for portion of your risk assessment, we need to make sure you're using SS1 and not safe torque off with just a general fast ramp. I mentioned that here, and I'll mention it again when I get a little deeper into that slide, but that is an important thing that I see overlooked often. All of these safety features are safety integrated level SIL 2, according to the 61508. Category 3, that's sort of an old ISO standard when we're looking at Cat 3, but the 13849-1 and PLD. And that is without additional contactors or anything else. This is going to be either via discrete I/O directly to the drive or control unit, or via field bus if you have a Siemens PLC, a safety Siemens PLC. So when I say field bus, I mean either Profibus or Profinet. We can use a safety telegram and not provide any wiring for all of those safety features and to those standards. I'll pause here for a moment. Where another thing I normally see or I hear often is that I need SIL 3 PLE safety. And certainly while that may be the case, my normal reaction is I would like to see the risk assessment that requires that. If you're not doing risk assessments today on your machines, you're running at least a legal risk equal to providing no safety on a machine or axis at all. The current safety standards require that you at least are going through the practice of doing a risk assessment to your machines. And if you do a risk assessment, it's really a win-win. You'll notice that whether you're looking at the IEC and we're trying to determine a SIL level, or whether you're looking at ISO and we're getting a performance level requirement, the risks to get into a SIL 3 PLE often involve a combination of death or loss of an eye or arm, and even then a regular frequency of being present, that your operator is in that condition on a regular basis. Now, what I see most of the time is no one wants an operator in that condition, so we have guarding or other safety measures just to keep them away from that. Now, there are applications where that's the case, where we do need SIL 3 PLE safety, but no, there's only one safety function that we can achieve that, and that is going to be a safe torque off, where we have removed power to the drive and motor completely with an additional contactor, and that means a coast condition. So to come full circle with why the risk assessment is so important, it wouldn't be too hard for an attorney to work backwards and say that a machine could have actually provided higher safety to an operator had we maintained control of the axis, even potentially to a lower safety category than what a coast could have done. Let's say a motor or something coast in and caused a pinch point and someone got damaged. Well, what if we had that stopped and held in position? So it's those kind of things that the safety boards want the practice. They want you going through, where are my risks and how can I mitigate them? They want you doing the risk assessment. More often than not, when a risk assessment is done, you'll find that the safety safety ratings of the drives is more than adequate. But I have had cases where we have to add a contactor. So really, we've got safety guys, Heinz or Steve. They can help decide what level you need if you're not comfortable doing it yourself. This is where they live all the time. Certainly not me, but I am aware of it, at least from this perspective. The next thing, when we're configuring safety, while it can be done on the drive, typically we're working with an integrated project or a drive to a PLC or something else, and we're using software to configure that drive. Today we have two softwares to do that. We have Starter and we have Start Drive. Starter has been around for a very long time. It's would have integrated in with the classic Step 7 environment. It's still used today for all of the drives. Really more commonly than Start Drive. Start Drive is the new TIA environment. I say new, but it's been around for 5 years, 6 maybe, and it's going through a lot of steps. The G series drives have been present in that since version 12, so they're pushing 3 years now as well. But the S series of drives, those S110, S120s, they are still not present for configuration in Start Drive. They're ever so close. It was expected to be a part of version 14 SP1. It did not make it. There's some beta versions out there that we can get. But for that reason, we like to sell and work with applications that we know will succeed and that will allow you to succeed. So there are times where we are still regularly using Starter for drive commissioning and then integrating with PLCs via, with a mixed project. For the purposes of this, after I talk about each safety function, I'm going to show you what that commissioning looks like in both software packages, because it is a little bit different. The names are the same, but sort of the paths to get to some of those menus are different. And of course, I'll start with that safe torque off. Safe torque off is really pretty simple. When we go into safe torque off mode, we are removing all power from the motor, and it just coasts down to whenever it will stop. This is literally that. We are removing torque generating power from the motor. Typically, this safety mode, if you want to consider it a safety mode, is used not necessarily to stop an axis because it's a coast, but it's actually a means of holding or preventing an axis from moving. So maybe there's another brake or something else to keep it from going. This is a way of preventing torque. The drives that we can find safe torque off in is that G110M, G120C. Remember I said there's some control units that don't have safety features in the G120. The control unit 230P-2 is intended for pump and fan type applications. Those typically don't warrant safety features, and as such, we don't see any there. But other than that, across the board, G120D, G130, G150, and those S series all include safe torque off capability as a basic function. It's there, it's ready for the use. Two other drives you've seen pop up here for the very first time, G110D and V20. V20 is an IP20 inside the cabinet. Very simple shaft turning drive. It really wasn't intended to have safety. This is maybe a bowl feeder vibration thing or even a pumper fan itself. Really simple, safe shaft turning. It does not include any safety functions as a result. And the G110D is a decentralized drive, similar to that G120, a little higher horsepowers, but again, shaft turning, very similar to V20 capability. So neither of those have that safety feature. For configuration of safe torque off, I'll start in the starter environment. This is the classic environment that you would see. For time purposes, what I have added is a G120 with a CU240E-2 PN, a Profinet. In this case, it's a fail-safe variant, meaning that I not only have the basic function, meaning safe torque off, but I additionally have those extended safety functionality. And then I've configured a power module and entered some motor data for a 10 horsepower motor, just so we can look at it. Where the safety functions are held, I've got a screen open here. I'll go ahead and close that. This is the way it would come up. It's going to be under Functions, Safety Integrated. We double click that. It used to be that this configuration absolutely had to be done while you were online with the drive. Around firmware 4.7, I'm not actually sure the exact firmware and software version, but we can do configuration now offline and then save, compile, and then download the parameter sets into the drive, including safety. And that's what I'm doing here. I don't have a drive here next to me. So offline, it's really as simple as we click this little drop down, and here's our options. We've got basic functions via onboard terminals. That would be like digital I/O. We've got basic functions via ProfiSafe. ProfiSafe would be Profibus or Profinet. It's really just a ProfiSafe telegram that we have. And by basic functions, we mean safe torque off. Just about anything else is going to be held under the extended functionality. There's some other options where we can do combinations of basic functions and ProfiSafe. We can also do that on the ProfiSafe and onboard terminals, or combinations of that. In this case, I will just look for now at via the onboard terminals. It's the most common that I see, so we'll head down that path. We'll look at some of the other later, but really with that selection, that's about all there is to it. We can see that out of the box, this control unit is looking for digital inputs 4 and 5 for our two channels, channel 1 and channel 2 of our safety. And with this, if we download, there's no additional work. If we were online and commissioning safety, there's some extra buttons down here where we have to copy the parameters to the other CU, or the other processor that's managing safety for redundancy. So we copy them before we activate, but when we download, it goes in together. We always want to make sure we do a copy parameters, a RAM to ROM after as well. So this little checkbox would do the RAM to ROM, as well as the the 2 processor copy. One thing that's often missed with the safe torque off configuration is that this box, this STO extended settings, that's actually a menu that we can select, and we get a few other things here. One is that FDI input filter, also the coincidence monitoring. So the coincidence monitoring would be how long do I have for the inputs to act different from one another. Sometimes there's mechanical variances, maybe on an e-stop button, where one input would make before another. And this is currently set to a half a second. That should be plenty. A lot of times you could tighten that up a bit. I normally see it left to default. But also an input filter for debounce. We don't want that kind of going in and out and in and out. The number one thing I see that's sort of overlooked in this menu, though, is the test stop timer. And right now it's set for 8 hours. This can be set for up to 9,000 hours, so a little over a year. What this is, whenever you have a safety feature in a drive, that safety feature, it really should be tested. In fact, the TUV requires that it be tested in some interval. By default, this has been set to approximately 1 shift. And what happens here is we can tie this condition off to a PLC or to an output or something to flash a light that we need to test it, but we need to cycle this condition. We need to create a safe torque off condition and reset it. Now, a lot of times I get a question from a customer, what's the right thing to put there? And, you know, whether you're talking to Steve Hines or myself or the other motion guys, you tell us. This directly will come back from your risk assessment. When do you think it's safe, or when do you think is the proper time to test the safety features of the drive? If it's a machine like a web process that may run once it gets going nonstop for days on end, well, you know, that doesn't make a lot of sense. Maybe you want to do this at a material change or tooling setup change, and maybe that only occurs once a month. So we would set this number of hours to approximately a month. Maybe you have a normal production machine where there's a shift change handoff, and as part of those handoff procedures, the operator activates safe torque off by hitting the e-stop mushroom head or whatever activates it, and then resets it. That activation automatically resets this timer. Now, what happens when the timer is elapsed? Really, it's a warning. It's telling you it's time to check your safety condition. It's not going to stop the machine. You're not going to get a fault. You're not going to end stop your process, but you will have a warning on the drive or anything else that you've attached to it once this time has been exceeded. Again, to reset it, we just activate the mode and turn it back off. All too often, I see people just jump this up to some magic, some really big number and make the problem go away. And while that does work, this does come back to that risk assessment. So I encourage you to look at whatever that timer should be. Normally, the 8 hours seems to be a nuisance. I get that call quite a bit. That's really focusing only on safety alone. That's how easy it is to configure that via onboard terminals. It's not a lot different if we went to look at it via Profi Safe. We're just getting that via Telegram now. We would have to configure communications for and add a Telegram. That's a little bit more set up here. I don't have a PLC to do, but this window is still the same. We still have this test time. Obviously, we don't have a discrepancy time issue now. It's coming over field bus, but we do still have this test stop timer input via onboard terminal. So if I go to look at the same feature then and start drive, which is TIA, I am using V14 SP1. It's the latest. It's up to date as of this morning. And I've added a drive that's configured. It's actually identical. I've got the same control unit, a 240E-2PN with failsafe, extended features, and I've got a power module and motor configured that are right about 10 horse. This can be found under the parameter window, and now we have, this is pseudo similar to the menu that we sort of had a breakdown in Starter. For those of you that are already using Starter, it's organized a little bit differently. I kind of like it once I get used to it, but it's difficult having used Starter for so long to get used to some of those keystrokes. So even here today, I may make a few a few errors, but the path is very similar. It was functions, now it's drive functions. We find safety integrated, and then we have a selecting safety functionality. Presently, I have none. If I want basic functions, this is one difference. I'm selecting whether I want basic or extended first. Whether I wanted Telegram or IO is actually done in start drive at drive commissioning stage. We can add it later, but that decision is made prior to the safety commissioning. If I say basic functions, here's where I can say controls type specifications. Well, basic is only STO. Here's the other place I can come back and say whether I want to do Profi Safe or terminals in both. If we just look at terminals, we can click that little button there. The window looks very similar in some ways and not so much in others. Really, this is only good to monitor the current condition of safe torque off. And then if you wanted to attach a parameter or condition to monitor that for logic. If you're looking for the test stop or the input information, those are under new selections over here in this tree. So this test stop is actually in its own little area. Notice the default is still 8 hours. We still have the same connection that we can make to that time here. Where now, rather than doing all in hours, we can actually do, we can monitor this a little bit cleaner. It's broke out a little bit better. Our inputs, here is that discrepancy time and our input filter. So it's the same information, but as I mentioned, it's broke out a little bit different. Now, one major change that I'm not overly fond of, we noticed that this input here, I don't see like I did in starter. This was digital input 4 and digital input 5. We don't see that here. And you're correct. There's some other places where we can look at that, but really the easiest is to look at our digital inputs, and now we can see where it was tied to here. Here's our digital input 4, digital input 5, or failsafe digital input 0 is now selected there. I see people a lot of times. I've had a couple phone calls where people go to look here. This is Telegram information, so notice there's no Telegram connection because I selected that this be done over field bus. So this isn't a complete configuration. To look at the complete I/O configuration, you want to be under the Inputs and Outputs tab to look at where this safe torque off signal is coming from. Let's see here. So that is safe torque off. I'm going to go through a lot of other safety features here, but really this is the most common. Motors kind of going along. We enter this mode, and either we coast to a stop or we maintain a stopped or coast status. We release torque from the motor when we enter this safe torque off mode. The next thing I'd like to talk about is safe stop 1. If you remember a little bit earlier, I talked about the big difference here is safe stop 1 is using a safety rated and monitored ramp for the motor, or for the axis, I should say. So we are following this ramp, and then once we've come to a stop, once that time has passed, we enter this safe torque off mode. If your risk assessment is saying that it's safe, if you have a stop time calculation, it's using 2 seconds, 3 seconds, whatever this time is, you need to be using SS1, not just the off 3 ramp along with safe torque off. As far as what drives that use it, it's pretty much the same. Safe SS1 is not part of the G120C, but other than that, it's pretty well across the board. One new thing we've seen here is this included. Included means that we have to make sure included versus available, that all these exclamation points, we have to make sure that we either select an F variant of the control unit or we get proper licensing. In the case of the S120, S110, it's proper licensing. Same for the CU250S for some other safety features, not this one. And then in the case of the CU240E, like I'm using, I notice I said I had a -F configured, a fail-safe unit. That means I get these extended features, which SS1 is a part of. if we want to look at configuration of SS1, we've got to go to those extended safety functions. We'll just keep it to onboard terminals. Notice this menu changes quite a bit when we go to do that. We now have this long list of the extended safety functions. Safety inputs and outputs are now seen here. We have, with this control unit, up to 3 safety inputs. That means 6 digital inputs on the drive itself. It takes 2 for each one of those safety. This is where we can configure those under the safety inputs and outputs. Your configuration tab here, this is where we have a stop time test. This is only a portion of this feature here. There's some other stop timers for some of the other safety features. So this would be used for like your STO, but some of the extendeds we have another stop timer as well. One thing when we start controlling the load, I've been using the term motor, and I apologize that whenever we have like a SS1 ramp, we're actually stopping the load. Now, it's possible that we have, and even likely that we have, some gearing involved. So one thing that is sometimes overlooked, we have to make sure that we get our mechanics here, and this is in a pole pair number. Now, I have a 4-pole motor, so that's 2 pole pairs, and I get 1 revolution of that to my motor pole pair. So this is something that you have to configure to properly control your load. And if you have gearing in play, we can also change our tolerance. We have to make sure we get this ratio of pole pairs and number of revolutions correct for maybe a non-integer type gearbox in order to properly control the load on that ramp. That mechanics input is one that's often overlooked. Beyond that, we make sure that we enable these extended safety functions. We can go into that SS1, which also includes a safe brake relay if you're using a safe brake relay. The SS1 tab just says, what's my safe RPM? And then we can configure that ramp. The relay, this is going to be the where the brake comes in, and also where the delay time and all of that comes in with that safe brake relay. So both of these are under this selection. Fairly self-explanatory. When I go back over to TIA portal, I have to go back to my functionality here. I am now going to go to extended functionality. It changed here again, but also we now have a larger list of functions here. Actual value sensing, we don't have an encoder, but that button is now going to bring me into this pole pair comparison, a lot of these same numbers, and this is where this mechanics has to be done because we're actually controlling the load, not necessarily the motor. As far as the SS1 itself, with SAM, this is a monitoring, acceleration monitoring, safe acceleration monitoring, so it follows a ramp more closely versus a safe brake relay. If we have that relay involved, you could use this. That same functionality is in starter with SAM, or whether we're using a safe brake relay. Let's see, let's go back out here. I'll buzz through a few more of the settings now. I'll just go through and talk about some of the other features. Safe torque off, safe brake control. This is going to SBC, so we're going to follow either a coast to a defined stop, or we're going to use that SS1 at that time. At the end of your SS1 ramp, in this case, this is when a brake will come on. That's pretty normal functionality there. There are some tricks to this. If you're using a hoist or conveyor type application, those can get a little bit tricky. Let me actually start the presentation. So that can get a little bit tricky. The drives that we have it on, again, these are dropping out as the safety functions become a little more advanced. We do have them across the board. We still have them with the G120. It's included. Safe brake control is included with the CU250S. We have to have a fail-safe variant with the CU240E. Safe limited speed, just as it implies. When we enter safe limited speed mode, the drive will decelerate as defined, and then we will get into and maintain below your defined speed. This actually shows it a fair bit lower. It will stay below, but it does dither much closer to whatever that speed set point is. An interesting point to safe limited speed: if you're using digital I/O to select your safety modes, you only have one speed selection. Whereas if we use field bus, ProfiSafe or the ProfiSafe over ProfiBus or ProfiNet, we can do up to 4. So there are some cases where you may want to have different speeds for your application, maybe robot presence versus operator presence or things like that. And that would be a case where we would have to use field bus versus I/O. But typically when you're needing safe limited speed, 1 is enough, and you could do that with I/O. Same, very similar control unit availability. However, this feature is in the G120D. Safe speed monitoring is a safety rated output that goes high when you're in the safety speed rating. So this could be attached to allow access a guard switch or a gate switch. Not a switch, but a lock to keep you in or out of an area, keep the operator in or out of an area. You could use that. Once we're below a certain speed, we can turn that output on. That could do whatever you wanted it to do. Then if the axis accelerates outside of that, that would go out. Again, you'd have to monitor and to ensure the operator has left that hazard area. But really, it's on anytime we're in that safe speed. Very similar offering in the drives to the other functions, and that's pretty much going to be the way it is from here out. Safe direction input. This is whenever this input is high, we only want to move in a positive, or we only want to move in a negative. Very, very common. I've had this a couple of times where conveyors need to always go one direction. There could be pinch points or some problems with it going in opposite direction, and this is a way to manage that. Again, very similar offering here as far as the way what control units and drives it's available in. So synopsis here, safe torque off, it's protection against unintended starts, although I do see it used often to stop a motor where a coast is okay, maybe it's a high friction or something. Again, risk assessment's gonna dictate that. Safe stop 1 causes the motor to stop in a safety rated manner. It's monitored and brings it to a standstill before going into a coast or STO. Safe brake control is going to enact a brake. Safe limited speed. We also have SS2. That's another feature where we bring it to a stop to come back to SS1. We do also have SS2 capability where we bring it to a stop but then hold motor torque. That being said, it's only available in some of the higher end drives. It's not in the GP mix, but it is a capability that we can do. Safe limited speed. We're monitoring that we are going at a limited speed while maintaining speed control at whatever your defined speed is. I'll show you where we can define that. Safe speed monitor. It's an output where it is high when we are in that safety mode, and safe direction is as an input where we're going to select that we only want to go one direction or the other. All those features pulled out here. Here's just putting all of those together on where we're at. Safe torque off is in the most across the board. SS1, really everything with the exception of safe brake control on the G120D, that's that decentralized drive, has no provisions for adding a brake relay, and that's why we don't see safe brake control on the G120D. But every other drive, very similar offering. Really, if you're looking for safety, we're probably going to be talking about a G110M, G120C for safe torque off, or we're looking at G120 and up in the family at G120 architecture. If I jump back into my VMs, we can look now at some of these other features. So I talked about safe limited speed. Now, because I've selected in this back menu onboard terminals, as I mentioned, I only have a safe limited speed configuration here for one stage. I only have one speed. If I were to come back here and say, what if I add both onboard and, I said basic, extended. Well, if I just go Profi Safe, and now we look at that safe limited speed, over Field Bus, we can select 3 additional speeds to decelerate the motor and maintain that safety speed for different conditions. Safe speed monitoring, it's really pretty simple, whether we're going to enable safe speed monitoring or not, what our filter time is, and then what the hysteresis and what that velocity control would be. So I want this on when I'm at or below that with a hysteresis. Again, we do get some dither there at that speed, so there's a hysteresis setting there. We can change whether that is active or inactive based on this condition of speed. Pretty self-explanatory stuff. Safe direction, again, we enable it and we say what our tolerance. Remember, this is using those mechanics we did with that pole pair to ensure that we're going the right direction, some of that information. So we need to make sure we get all that right, but then we have these for positive and negative limitations. All of this configuration can be done online. Again, just a little bit different configuration here. We do a copy to processors, then we activate. There's some extra buttons. Or offline like I am here, we just can download after we save. Because the drives are not a PLC, right? Everything is in a parameter. Everything has a placeholder. Whether you configure in Starter, or I'll go through most of this here in Start Drive, whether you configure in Start Drive, you can go online with the drive. You can use accessible nodes. We can upload those parameters and use either way. So let's say if you're developing a machine, but then your customer wants to use Starter versus Start Drive, there's no issue with that. It can be uploaded and then viewed. Safe limited speed, again, whether we're using with a delay time or whether we're going to use a safe brake relay, and the ramp setting here, your ramp monitoring and ramp. This is all very much the same as what we saw in Starter. It just looks, the presentation is a little bit different, but all of the names, all the information is the same. Same for safe speed monitor. These are even all of the same defaults, which really they should be when we go to look at that. Actual value sensing does look a little bit different when we start adding some extra features, including one of the things I wanted to find here was our FDI, FDO assignment. So we only have 3 inputs with this control unit. So when I go to apply them, this is where I would select what I'm using and what is wired to say who. So in this case, I've got FD0 for safe torque off, FDI2 for SS1, FDI1 for a safe limited speed. If I come back and I then look at, our digital inputs, we see that we have consumed many of our I/O in using that. I typically see I/O used when we're using maybe an Allen Bradley PLC or a Schneider or somebody else's PLC. If we're using Siemens, really the typical installation that I get involved with will be Field Bus because of this I/O consumption that we have. Right now, I already have sort of a problem. I'm double duting here that this was pre-configured with jog bits on these positions, but now it's also my safety input. So this would need to be rectified, and that needs to be done manually prior to a download. My biggest fear with a webinar like this, where I can't see and I can't talk to people and I don't know actual applications, is everybody has sort of their own needs, and a lot of people want very specific things. So other features that we can add: safe stop 2, again, safe operating stop. We also have safe brake test, safe limited position, and safe position. That would be an output. All of these are going to be in the S series family, but that doesn't mean we can't just use volts per hertz and again, volts per hertz or vector or anything else in that family if you need these additional features. If you need these additional features, and I know I absolutely blasted through the configuration in a very, very generic manner, without an application, it's tough to be much, much more focused. Please don't hesitate to contact any of the C&E motion specialists, Steve Wright, Hines. We can all get you squared away on what modes are available and how to get you successfully using them. I honestly believe Siemens has a very dynamic portfolio of safety options in their VFD drives, especially when you go to look at over field bus with a PLC. This little screen here, when we send out the follow-up email, I've already passed along a website, a web link that can help. It goes through all of the functions of the drives. It explains them quite well. Maybe, looks like I've got a little bit of an internet problem. You can go in here and you can read up more on each one of these safety functionalities. It's a nice pop-up dialog. I'm going to make sure that everybody that's registered and participating is going to get a good link to this website, as well as you will get a brochure that normally brochures don't include a lot, but the Siemens safety brochure is actually very inclusive, and it's where many of the screenshots in my presentation actually came from. It will help as well. So there'll be a little bit of desk material for you to read and kind of leaf through, but do not hesitate to contact any of us to help with safety. It is very application specific, which leaves it maybe a little bit of a challenging presentation, but hopefully you got something out of this. And with that, I am into questions.
Thank you, Jay. At this point, we don't have any questions that anybody has submitted. If you have questions for Jay concerning the safety features in the Siemens VFDs, please use the control panel question box over on the right-hand side of your screen to enter those, and we will field those questions for you. While we're waiting to see if anybody submits any questions, to Jay's point, if you have specific applications that you need some advice on, we have a staff of 14 engineers. Jay happens to be one of our motion and drives guys, and there are 4 of those guys. And then we have guys that focus on automation, and then we have guys that focus on machine safety, guys that focus on vision. And so we've got the various disciplines that these guys get to spend all day, every day doing. And so we have 2 safety engineers, Heinz Knackstedt and Steve Wright, are both well-versed in the safety standards and applications and so forth, and can provide guidance. So if you need help in that area, feel free to coordinate that through your sales rep, or you can contact me here at our Dayton office at 800-228-2790, and I can put you in touch with the right person. Jay, we don't have any questions that have come through, so at this time we will end the webinar, and everyone, there will be a link sent out to everyone who registered for the webinar, so you will get a recording of this. Jay, thank you for a job well done.
Thank you. Thanks to everyone who joined.